Hello there. Welcome to our Capstone presentation for natural language processing applied to mental health. We're the Cognitive Care Crew, a team of 5 software engineering students from McMaster who are working alongside Dr. Mosser and a team of experts at University of Quebec in Montreal. We've been working hard this year to create new and exciting software artificial intelligence models which have a variety of applications and use cases, capable of recognizing and diagnosing various mental health afflictions. But let's slow that down a second and do a little bit of backtracking. How did we get here? As society becomes more conscious of the ever-growing prevalence of mental health issues, the demand for support services is climbing fast. But at the same time, the wait times are climbing even faster. More Canadians than ever are unable to get the support that they need, whether that be from system backlog, limited access to services, or even just because of mental health stigmas that prevent them from reaching out. The Canadian Centre for Addiction and Mental Health reports that in any given year, 1 in 5 Canadians experiences a mental illness. And it's estimated that 50% of these individuals are not being treated. So, what are we going to do about this? Obviously, the topic of tackling the multifaceted problem of a mental health crisis does not have a clear-cut solution that could be easily implemented by a small team of software engineering students. But luckily for us, there's a very talented team of engineers, researchers, and mental health specialists who have organized the eRisk competition, a yearly competition where schools from all over the globe come together to explore methodologies, metrics, and applications of creating early risk detection technologies for the internet. Every year, eRisk releases 3 different tasks, tackling different use cases and issues for a wide range of research areas and potential applications. Field experts use a variety of different metrics and organizational structures to measure the accuracy of each task, along with applying different constraints to achieve a closer approximation to the real-world characteristics. All tasks are centered around using machine learning technology known as an NLP, a natural language processor. NLPs are a field of artificial intelligence allowing for machines to break down and interpret human language. These algorithms are fed training data and expected outputs to build a knowledge bank of associations and patterns, and then it uses that data to try to make classification predictions on new sets of data. Building and optimizing these models requires a lot of experimentation and hard work, not to mention a major time investment. We definitely would have been overwhelmed trying to balance more of the front-end and organizational aspects of managing this project scope. But luckily for us, we had the help of a fellow Capstone, the NLP Ops team, to help us out on that front. They collaborated with our supervisory teams to assist with the project deployment. I won't go into too much detail on that aspect, I'll leave it for their presentation. But in terms of our own contributions, as mentioned before, the bulk of the work can be broken down into 3 primary tasks. So the first task is based on searching for symptoms of depression. The experts over at eRisk have decided to use a survey known as the Beck Depression Inventory, intended to break down depression into 21 unique symptoms. Using the training data provided, we broke down the sentences from participant data and then used generative artificial intelligence techniques to rank each word into a corresponding severity of a depression symptom. Using these custom libraries, this model is capable of looking at a series of sentences and making independent decisions on which sets of sentences have the highest correlation for a depression symptom. Task number 2 is for early detection signs of anorexia. The task is centered around the idea of creating and optimizing a model for detecting symptoms with the smallest amount of information possible. You see, the sequential release patterns of user data is meant to imitate the real-time posting behaviors of people on social media. Every time the system is going to receive a new round of posts, it can reevaluate its decision on whether the selected user is displaying risk signs. This way, it can try to formulate the most accurate decision as quick as possible. The driving idea is meant to identify people with mental health issues and mitigate these issues before they get worse. The final task was measuring the severity of signs of eating disorders. So using provided data from the eRisk study, we're given copies of participant Reddit post history and a copy of their results from filling out the Eating Disorder Examination Questionnaire, better known as the EDEQ. A major challenge posed from this is that the constraints of the competition only had a small number of participants present in the training data, and a small number of posts per user. This left the data kind of feeling unfocused and difficult to train a specialized prediction model with. The solution that the team came up with was challenging conventional data modeling strategies. Instead of each individual in the study having a set of scores attached to their profile, it was organized such that each post would have a set of scores associated with it. This immensely helped improve the relative pattern accuracy. The applications for a system like this are nearly endless. I mean, if properly adapted into more social media applications or digital spaces, of course under the guidance of ethicists and mental health professionals, this could be a game changer for online safety and diminishing barriers for better mental health resources. Although each of the models have been trained to fit competition guidelines, if there was more widespread support with varied datasets, these could be adapted for nearly any affliction or to help anyone exhibiting a harmful behavior. I mean, with the right guidance, technology such as this could pave the way for a brighter, safer internet for everyone. Thank you for your time.